Good morning, children. In the previous class, we have seen study of compounds. In study of compounds, we completed hydrogen chloride. Today, let us see the second topic, NH3. NH3. What is NH3? It is nothing but ammonia. Today, let us see about the compound ammonia. What does ammonia consist? Ammonia consists of nitrogen element and 3 hydrogen elements. Nitrogen plus 3 hydrogen elements giving rise to ammonia compound. Chemical formula of ammonia is NH3. Chemical formula of ammonia is NH3. Relative molecular mass. Coming to the relative molecular mass, we know molecular mass of nitrogen is 14, hydrogen is 1 into 3 plus 14, 17. So, our relative molecular mass of ammonia is 17 grams. Coming to the bond, what type of bond is present between nitrogen and hydrogen? Covalent bond. What type of bond? Covalent bond between nitrogen and hydrogen. If you see, nitrogen atomic number is 7, electronic configuration is 2, 5, and if you see how many lone pair of electrons are there, 1 lone pair and other three non-lone pair electrons we are having. So nitrogen, if you see here, this is a lone pair electron, unpaired. So nitrogen 5 electrons are there, this is already paired up. In 5 electrons, we can see this is lone pair and other 3 are not lone pair. Okay, then hydrogen, how many hydrogens are there? 3 hydrogen. Atomic number of hydrogen is 1. So its electronic configuration is 1 and we are having 1 electron. So what will happen? This 1 electron of nitrogen as well as hydrogen, they will share one another and it will form ammonia molecule. What type of molecule here? Ammonia molecule. And here we will find a covalent bond. Sharing of electrons takes place, therefore we can find covalent bond here. Okay, so this is about the introduction part of ammonia. Once again, ammonia chemical formula is NH3, molecular mass is 17 grams, type of bond is chemical bonding, covalent bonding. Type of bond is covalent bonding. Occurrence, where does ammonia occur? Ammonia, it will be occurring in traces in air and also in natural water. Ammonia, we can see traces of ammonia in water as well as natural air. And also we can see ammonia in combined state of ammonium chloride and sodium and ammonium sulfate. In combined form we can see in ammonium chloride and ammonium sulfate. We can also see this ammonia, it is present in urine. NH2CO NH2, it is also present in urine, NH2CO NH2. So whatever it may be, where we will get this ammonia? Ammonia, its traces of ammonia are seen in air as well as in water. Secondly, ammonia is seen in compounds of ammonium chloride and ammonium sulfate. And thirdly, ammonia is also present in urine. Okay, now let us see about the laboratory preparation of ammonia. How can we prepare ammonia in a laboratory? Chemicals, what are the reactants we require? We require the reactants like ammonium chloride and calcium hydroxide. What we require? Reactants ammonium chloride and calcium hydroxide. So this ammonium chloride and calcium hydroxide, when they react with one another, what we get is calcium chloride, water and ammonia. This is the equation. Just I am explaining to you about the equation, children. What we are taking? Ammonium chloride, calcium hydroxide. When we take, we will get calcium chloride and water as well as ammonia. So balancing of the equation, if you see 2, 6, 7, 4, 6, 7, 8, 9, 10. Okay, 8, 9, 10. Right. So this is the balanced equation. Okay. So once again, what are the reactants we require in the lab preparation of ammonia? ammonium chloride and calcium hydroxide. Now let us see how we will prepare it. Now firstly what we will do is we will take one round bottom flask. We will take one round bottom flask. This round bottom flask, what we will do is we will take it in a tilted position. We will take this round bottom flask in a tilted position. Okay. In this round bottom flask, what we will take ammonium chloride and calcium hydroxide. What we do is we will take ammonium chloride and calcium hydroxide, which is finely grinded. They are finely grinded, and we are taking a round bottom flask. This round bottom flask also, how we are taking? We are taking in a tilted manner with a one-hole rubber stopper. With a one-hole rubber stopper like this. Now, here why we are taking this round bottom flask in a tilted manner? So when we are heating this one, what will happen is ammonia is evolved. Now when ammonia is evolved, traces of water also will be there. So this water, what will happen? It will be tricking and it will be coming back. So in order to avoid that, what we will do is we keep the round bottom flask in a tilted manner. Now for this, what we do is we take calcium oxide or quicklime, and here this is the position of ammonia collection. So once again, let us see in lab how do we prepare ammonia. So what are the reactants? Ammonium chloride and calcium hydroxide. What we did, these are the reactants. So reaction C, 2NH4Cl plus CaOH twice gives rise CaCl2 2H2O ammonia. Now let us see about the apparatus. So if you see the apparatus, you can see one round bottom flask here. Now this round bottom flask, what I told, we have to put in the tilted position. Round bottom flask, what we are doing? We are putting in a tilted position. Now what we do is firstly, ammonium chloride and calcium hydroxide, are finely grinded and taken in a round bottom flask. Calcium hydroxide and ammonium chloride are finely grinded and taken in a round bottom flask, fitted in a slanting position. We are taking in a slanting position. Why we are taking in a slanting position? The flask is tilted in such a way that the water formed in the reaction does not trickle back. So when the reaction is going on, what will happen? The water formed in this one will not trickle back. So in order to avoid that, what we are doing? We are keeping the round bottom flask in a tilted manner. Now here, what we do is, now from this, what is observed? Ammonium chloride and CaOH twice, when it is heated, ammonia is produced. With this ammonia, what is produced? Water also produced. In order to not to allow the water back, we are keeping this round bottom flask in a tilted manner. So ammonia as well as what is produced, water also produced. So what we will do is, this is called as a drying chamber. This is called as a drying chamber. So ammonia, which we are getting, what we have to do? We have to dry it. So drying of ammonia gas. The gas is passed through a drying tower. So this gas is passed through a drying tower containing lumps of calcium oxide. So ammonia is the produced ammonia is passed through the drying chamber in which calcium oxide is present. Now, not only calcium oxide, we can also use sulfuric acid, we can also use phosphorus pentoxide, we can also use calcium chloride, but we are not using. We can use P2O5, we can use CaCl2, or we can use corn H2SO4. We are not using. Why we are not using? Because ammonia is basic in nature. Therefore, since it is basic in nature, it may react with them. That's why we are not using corn H2SO4 or CaCl2 or P2O5. We are only using calcium oxide. Okay. Now coming to the collection of ammonia. How do we collect ammonia? Ammonia is collected by downward displacement of A as it is lighter than A. Ammonia is collected by downward displacement of A as it is lighter than A. and since it is highly soluble in water, we cannot be collected in water. Since it is highly soluble in water, we are not collecting ammonia with the help of water. Okay, so this is how we prepare ammonia in the lab. What are the reactants? Ammonium chloride and calcium hydroxide. What we are doing? We are taking a round bottom flask. That round bottom flask, what we are doing? We are grinding ammonium chloride and calcium hydroxide. Finely grinded powder is kept in that round bottom flask and we are heating it. When we are heating it, what happens? Ammonia is produced. Now, why we are keeping the round bottom flask in a tilted manner? We are putting this round bottom flask in a tilted manner because the water traces which are released after heating it may enter the round bottom flask. It may trickle or it may damage the round bottom flask. Therefore, we are putting the round bottom flask in a tilted manner. Now, after the production of ammonia with the help of water, what we are using? We are using a drying chamber. This is called as a drying chamber. In this drying chamber, what we are using? We are using calcium oxide. We are using calcium oxide to remove this water content from that. And also with this, we can also use phosphorus pentoxide, calcium chloride or con H2SO4. Why we are not using this? We are not using this one because our ammonia is basic in nature. It may react with that. Therefore, we are using only CaO. And then we are collecting this ammonia in a collector. And while collecting also, we are following the process of downward displacement of air. Why we are using this downward displacement of air? Because ammonia is lighter than air. Since it is highly soluble in water, since ammonia is highly soluble in water, it cannot be collected, ammonia cannot be collected water. So this is how we can prepare ammonia through the laboratory. If you see the final equation, 2NH4Cl plus CaOH twice gives rise CaCl2 plus 2H2O plus 2NH3. So this is how we can prepare ammonia through the lab. Also, ammonia can be prepared from metal hydrates also. We can prepare, second method of preparation of ammonia is, we can prepare ammonia even with the help of metallic nitrates like Mg3N2 and ALN. What we can use? How can we prepare through metallic nitrates? We can take metallic nitrates like magnesium nitrate and aluminum nitrate with the help of water. MgOH twice plus NH3 AlOH plus ammonia. So this is how, these are the two methods of preparation of this ammonia. See, once again, see, metallic nitrate Mg3N2 plus H2O gives rise MgOH twice plus NH3. Here we will write 6H2O. If you write, see the balancing of the equation 3Mg. Here ALN, 2ALN plus 3H2O, ALOH thrice plus NH3. So if you see ALN, no need to do ALN plus 3H2O, 36N1. Okay, right. So Mg3N2 plus 6H2O gives rise 3MgOH twice plus NH3, 2NH3 will get, and ALN plus 3H2O gives rise ALOH thrice plus NH3. So these are the two equations you have to put in your mind. Preparation of ammonia through metallic nitrate. Which metallic nitrates we are taking? Two metallic nitrates we are using. One is magnesium nitrate, other one is aluminum nitrate. If you react with water, we will get magnesium hydroxide and ammonia, and aluminum hydroxide and ammonia. These are the two methods of preparation of ammonia through metallic nitrites. Okay. Now, how can we prepare aqueous ammonia? Aqueous ammonia. Already we have seen, which is called as funnel experiment. Do you remember funnel experiment, children? Aqueous ammonia means water. We have to mix ammonia and water. So what we did, funnel experiment means what we did, we will pump HCl also will be solved. We will pump ammonia, and what we will do, we will use one funnel. We will use one water trough. Do you remember? So what we are doing, we are using an inverted funnel. We are pumping ammonia. Here we are having a water. condition, we have to see that funnel is in on the surface of the water. So what happen when ammonia is passed through this one, it will back suction can be observed, water will be collected into the funnel, and because of variation of pressure, again what will happen, this water and ammonia will be dissolved in this water. This process continues until it is saturated. So this one we have seen in HCl also, same process we can prepare ammonium hydroxide, aqueous ammonia. Okay, this is called as funnel experiment. So what we did, we will take an inverted funnel over the surface of the water. We will pump ammonia. When we pump ammonia, due to back suction, what will happen? Water will be sucked by this ammonia into the funnel. This process continues due to the variations of pressure. Again, the water sucked will be dropping into the water trough. This process continues until the water is saturated. So like this we can prepare saturated, like this we can prepare aqueous ammonia. Okay, next important topic is preparation of ammonia through Haber's process. Very important, Haber's process. Haber's process. Preparation of ammonia through Haber's process. Haber's process, if you see reactants, what are the reactants? Reactants are nothing but nitrogen and hydrogen. Nitrogen and hydrogen. So both this, if you see the chemical equation, both this will react together to form ammonia and heat. You can find heat. It is a reversible reaction of such a. So N2 plus 3H2 gives rise to NH3 plus heat. This is the equation for Haber's process. So what are the reactants we are taking? We are taking nitrogen and hydrogen. Nitrogen and hydrogen. We are producing ammonia. These are the reactants. Now, how we can prepare this ammonia? Now, for example, if you see nitrogen and hydrogen, they are available in the free air. So, through the fractional distillation, of this liquid, we collect nitrogen, and through the fractional distillation of this or through the hydrogen, either through the water gas or either through the natural gas, we can produce this hydrogen. So once again, see how can we get nitrogen? Nitrogen, we are collecting this nitrogen in the free air by the fractional distillation. Hydrogen, we are collecting this hydrogen with the help of water gas or natural gas. Okay, now this, if you see the reaction, nitrogen and hydrogen, they are reacting with one another for the production of ammonia, which is a reversible reaction, and it is an exothermic reaction. Now, since it is a reversible reaction, what happens here? There is a decrease in volume. Nitrogen, if you see how many volumes we are taking, we are taking 1 volume of nitrogen and 3 volumes of hydrogen. We are getting only 2 volumes of ammonia. So what we are observing? We are observing that the volume is decreasing. So why the volume is decreasing? Because of the efficiency of ammonia. To increase its efficiency, we can find that ammonia is decreasing. Now conditions. We are having some conditions when we are preparing this one. So conditions, temperature is maintained from 450 degrees centigrade to 500 degrees centigrade, and pressure, we require a pressure of 200 atmospheric pressure. And catalyst is finely divided iron. We require finely divided iron. And promoter, we use either molybdenum or Al2O3. These are the conditions we have to put in our mind. We are having 4 conditions in the Haber's process. One is 450 to 500 degrees centigrade. Second one, 200 atmospheric pressure. Catalyst, finely divided iron. And promoter, molybdenum or Al2O3. Now let us see how can we prepare this Haber's process. So what we do is, we will take nitrogen, we take hydrogen. In which ratio? In the ratio of 1:3. We take in the ratio of 1:3. We take it 1:3. Now after this one, what we do is, we have to we have to take a temperature of 500 degrees centigrade. So what is the temperature we told? 450 to 500 degrees centigrade. So we apply a pressure of temperature of 500 degrees centigrade. Okay. Now what we do is what we do is we maintain a pressure of 200 atmospheric pressure, and we use a catalyst which is called as a finely divided iron and a promoter like molybdenum, and we can collect this ammonia gas. So we are getting ammonia gas. So N2 plus 3H2 gives rise to NH3. So we are getting ammonia gas. So once again let us see about this Haber's process. As you have seen, it is an exothermic reaction. What reaction, children? It is an exothermic reaction. So once again let us see what is Haber's process. Haber's process, the name Haber is given for the preparation of ammonia. What is the chemical equation? N2 plus 3H2 gives rise to NH3. It is a reversible reaction. It is an exothermic reaction. What are the reactants we require? We require the reactants like nitrogen and hydrogen in the ratio of 1:3. Now, what are the conditions we require? Conditions: temperature 450 to 500 degrees centigrade, and pressure 200 atmospheric pressure, catalyst finely divided iron, and promoter molybdenum or Al2O3. So in lab, how do we prepare, or how we will get nitrogen and hydrogen? Nitrogen we are getting from the air by fractional distillation. How we are getting hydrogen? Hydrogen we can collect by water gas or natural gas. So what we are doing, we are pumping this nitrogen and hydrogen like this, and we are taking to a electrical chamber which is maintained at a temperature of 500 degrees centigrade, because condition, what kind of condition? 450 to 500. So we are maintaining a temperature of 500 degrees centigrade, and at the chamber, catalytic chamber, this is called as a catalytic chamber. At this catalytic chamber we are maintaining a pressure of 200 atmospheric pressure and a catalyst finely divided iron, and the promoter is molybdenum. And then because of this compression, what we get is we'll get ammonia, and this ammonia is it is an exothermic reaction. Why it is an exothermic reaction? Because heat is released. And if you see the volumes, 1 volume of nitrogen plus 3 volumes of hydrogen, it is giving 2 volumes of ammonia. That means here we can observe there is a decrease in the volumes. There is a decrease in the volumes. Now, nextly, coming to the physical properties. What are the physical properties of ammonia? Ammonia is colorless, and it is having a strong pungent choking smell. It is colorless and it is having a strong pungent smoking smell, and it is basic or it is alkaline, and it is non-poisonous. It is non-poisonous. It is highly soluble in water. Already we have seen highly soluble in water. Fountain experiment we have seen in HCl. Here also we can find the same experiment here also. Let us see once again how to do this fountain experiment. So what we do is, we will take one round water. I will draw the rough figures. We will take one round water flask, 2-hole rubber stopper. This completely is filled with ammonia gas. It is filled with ammonia gas, and we will have a ink dropper. In this ink dropper, what we are using? We are using water, and we are having a jet tube. This jet tube, there we used blue litmus. Here we use red litmus. Red litmus solution. So round water flask, 2-hole rubber stopper, one ink dropper, other one nozzle, and red litmus water trough. Now how we will explain? This is called as a fountain experiment. Why we are using this fountain experiment? To show that ammonia is highly soluble in water. There we have seen HCl is highly soluble in water. Here also we have seen ammonia is highly soluble in water. So what we did, we completely filled with this round water flask with the ammonia. So here we are having an ink dropper. Ink dropper, what is present? Little amount of water is present. So just we will pierce little amount of water inside it. So when we pierce little amount of water inside it, ammonia is dissolved in this water. Ammonia is dissolved in this water. Therefore, little amount of vacuum is present. Little amount of vacuum is present, and we can find here there is a decrease in pressure. Because there is a decrease in pressure inside, there we can find outside there will be an increase in pressure. Because of the increase in pressure, because here there is a decrease in pressure, here there is an increase in pressure. Because of the increase in pressure, the red litmus will be passing through this nozzle. So, and when it has entered here, when it is coming outside, since ammonia is alkaline, since ammonia is basic, it will change this red litmus solution into blue in color. This says that two things it will say. One is ammonia is soluble in water. Second one is ammonia is basic in nature. Therefore, it changed red litmus solution into blue in color. So this is called as fountain experiment. Same experiment we saw in HCl to prove HCl is soluble in water. To prove HCl is acidic in nature. Now we are same fountain experiment we are taking and we are proving ammonia is soluble in water and ammonia is basic in nature. Okay, so this is one of the physical property we have to see that ammonia is soluble in water. Okay, next coming to the chemical properties. Ammonia, we can find thermal dissociation in ammonia. Thermal dissociation means what? When we heat ammonia, it will be dissociating into nitrogen and hydrogen. We can find it will be dissociating into nitrogen and hydrogen. This is called as thermal dissociation. When we are heating this ammonia, what will happen? We can find that it will be dissociation, decomposition can be seen, nitrogen plus hydrogen. It is a reversible reaction. Secondly, this is thermal dissociation. Secondly, burning of ammonia in oxygen. What will happen when ammonia is burnt in oxygen? We can find that when ammonia is burnt in oxygen, NH3 plus O2. When ammonia is burnt in oxygen, we can find that there will be a production of nitrogen and water. Very important equation. When ammonia is burnt in oxygen, what is produced? Reddish brown fumes of nitrogen and water. Okay, now let us see about the balancing of the equation. So 4NH3, 3O2, 2, and the water 4 3s are 12, 6H2. Okay, burning of ammonia with oxygen. When ammonia is burnt with oxygen, we will get nitrogen and hydrogen. So what is the color of this nitrogen? Yellowish blue flame. We can find yellowish blue flame of nitrogen. Very important equation, put in your mind. Ammonia treated with oxygen, we will get nitrogen and water. What is the color of this nitrogen? Yellowish blue flame. Next, catalytic oxidation of ammonia. Third one is how oxidation can be explained with ammonia. So ammonia, when it is oxidized, NH3 plus O2, when it is oxidized at a condition we are having catalyst platinum and temperature of 800 degrees centigrade. We are using a catalyst platinum at a temperature of 800 degrees centigrade. If you use, we will get nitric oxide and water. Nitric oxide and water, NO. Okay, so let us see once again. Ammonia when treated with oxygen with a catalyst platinum at 800 degrees centigrade, we will get nitric oxide. NO is called as nitric oxide plus water. If you look at the balancing of the equation, 4, 5, 4NO, 6. Okay, so this is how we balance the equation. Put in your mind this equation. Ammonia treated with oxygen with platinum catalyst 800 degrees centigrade will get nitric oxide and water. Now what is this? What is the color of this nitric oxide? It is a brown gas. Again this nitric oxide, nitric oxide when treated with oxygen, we can get nitrogen dioxide. We can get nitrogen dioxide, brown gas of nitrogen dioxide. And next, reducing agent. How ammonia is used as a reducing agent? Say ammonia when treated with copper oxide, which is black in color, copper oxide solid black in color, it will be dissociated as copper, water. It will be dissociated as copper, water, and nitrogen. This is also gas. Important equation. So ammonia when reduced with black mass of cupric oxide CuO, it will get copper, water, and nitrogen. This is a black solid. So ammonia plus CuO gives us Cu plus water plus N2. This equation is called as reduction of reducing agent. Ammonia is a reducing agent. This equation says that ammonia is reducing agent because it is reducing cupric oxide to copper. The black color copper oxide will be converted into copper. So this is the example given to say that ammonia is a good reducing agent. Next, reduction of chlorine. Reduction of chlorine to HCl. Now, if you take ammonia and chlorine, how it is reduced when we are taking it will get nitrogen and hydrogen chloride. Nitrogen and hydrogen chloride. Again, if you take this excess of ammonia, suppose after production if you take excess of ammonia with HCl, excess of ammonia with HCl if you take, will get ammonium chloride. Okay. Now similarly, if you take ammonia with excess of chlorine, if you take ammonia, this is what we are saying excess of ammonia. Here chlorine is excess. If you take ammonia with excess of chlorine, we will get HCl and NCl3. Balancing I am not doing, children, just go through the equation. So ammonia with chlorine, when excess of ammonia is treated with chlorine, what we are getting nitrogen and HCl. Or when ammonia is treated with when excess of ammonia is treated with HCl, we are getting ammonium chloride. Now if you see ammonia when treated with excess of chlorine will get hydrogen chloride and nitrogen trichloride. Okay, so these are some of the equations you have to put in your mind. First equation we have seen thermal dissociation. Thermal dissociation means ammonia. When ammonia is heated, it is dissociating into nitrogen and hydrogen. Secondly, we have seen burning of ammonia in oxygen. So when ammonia is burned in oxygen, we are getting nitrogen. And thirdly, we have seen oxidation of ammonia. When ammonia is oxidized, it is turning into nitric oxide. Fourthly, we have seen how ammonia is acting as a reducing agent. So when ammonia is treated with the black cupric oxide, it is reducing into cupric oxide is reduced to copper. Then we have seen how the reduction is carrying out in ammonia. So when excess of ammonia is treated with chlorine, we are getting nitrogen, and when this excess of ammonia is treated with HCl, we are getting ammonium chloride. And similarly, when ammonia is treated with excess amount of chlorine, we are getting hydrogen chloride and nitrogen trichloride. Okay, and another aqueous solution of ammonia. So when ammonia is treated with water, what we are getting ammonium hydroxide. So this ammonium hydroxide, when it is treated with HCl, when it is treated with H2SO4, or when it is treated with HNO3, what we will get? So ammonium hydroxide, how we are getting ammonium hydroxide? When ammonia is treated with water, so NH4OH. So this NH4OH, when it is treated with HCl, we are getting ammonium chloride. This NH4OH, when it is treated with HNO3, we are getting ammonium nitrate. This NH4OH, ammonium hydroxide, when it is treated with sulfuric acid, we are getting ammonium sulfate. So like this we can find, we can produce ammonium chloride, ammonium nitrate, and ammonium sulfate. So this is about your aqueous solutions of ammonia. Similarly, in 4th chapter analytical chemistry, we have seen some equations how ammonia, ferrous sulfate, what happens when ferrous sulfate is treated with ammonia? What happens when ferrous chloride is ferric chloride is treated with ammonia? What happens when lead nitrate is treated with ammonium hydroxide? What happens when zinc nitrate is treated with ammonium hydroxide? What happens when copper sulfate is treated with ammonium hydroxide? So once already we have seen, just let me recap that one. So firstly, ferrous sulfate, FeSO4. So when ferrous sulfate is treated with ammonium hydroxide, what we are getting? We are getting a dirty green precipitate of ammonium sulfate. Okay. Now similarly, ferric chloride. When ferric chloride is treated with ammonium hydroxide, we are getting reddish brown fumes of ferric hydroxide, which are insoluble. Thirdly, when lead nitrate, colorless lead nitrate, when treated with ammonium hydroxide, we are getting a colorless precipitate of lead hydroxide. And fourthly, when zinc nitrate is treated with ammonium hydroxide, which is colorless, we are getting white gelatinous precipitate of zinc hydroxide. Lastly, when blue colored copper sulfate is treated with ammonium hydroxide, we are getting a pale blue of copper hydroxide. So these are the when blue color of copper sulfate is treated with the CSO4 is treated with the NH4OH, we are getting a pale blue precipitate of copper hydroxide. All this we have studied in analytical chemistry. So once again, let me say, first one is regarding ferrous sulfate, FeSO4. Second one is ferric chloride, FeCl3. Third one is zinc nitrate. Fourth one is lead nitrate. Fifth one is copper sulfate. So whatever it may be, first one, that is ferrous sulfate, when we are treating with ammonium hydroxide, what we are getting? We are getting a dirty green precipitate of ferrous sulfate. Second one, ferric chloride, when treated with ammonium hydroxide, we are getting a reddish brown precipitate of ferric hydroxide. Lead nitrate, when treated with ammonium hydroxide, we are getting a dirty white precipitate of ammonium hydroxide. Zinc nitrate, when treated with the ammonium hydroxide, we are getting a white gelatinous precipitate of zinc hydroxide. Lastly, when calcium sulfate, blue colored copper sulfate is treated with ammonium hydroxide, we are getting a pale blue precipitate of copper hydroxide. So these are the some of the examples of this ferrous sulfate, ferric chloride, lead nitrate, zinc nitrate and copper sulfate. All these we have studied in analytical chemistry. Just go through that, whether they are insoluble or whether they are soluble, whether see about their colors. Already this will be useful for observation. And next lastly about test. What are the tests? We already seen it is having a colorless, and it is a strong pungent choking smell. And if you see, it is basic in nature, therefore it turns turmeric paper brown. And if you see phenolphthalein solution, it changes phenolphthalein solution into pink. So already we have seen about this one in basic character. Next, lastly about the uses. What are before that, when ammonia is treated with HCl, we will get a white exclusions of ammonium chloride. This is also a test for this ammonia as well as test for HCl. Coming to the uses, liquid ammonia, it is used as a refrigerator in ice plants. Liquid ammonia is used as a refrigerator in ice plants. Secondly, it is used to remove grease stains. Ammonia is used to remove grease stains or dirty stains from the clothes. And ammonia is used as a nitrogen fertilizer. It is used in the preparation of nitrogen fertilizers. And ammonia also used as a explosives. Ammonia is also used as a explosives. So once again, what are the uses of ammonia? Ammonia is used as a refrigerator in ice plants. Ammonia is used in the preparation of fertilizers. Ammonia is used to remove grease stain from clothes, and ammonia is also used in explosives. If you see explosive in the form of ammonium nitrate, we get nitrous oxide N2O. So these are the uses of ammonia. So today's class we have seen about the occurrence of ammonia. We have seen how to prepare ammonia in the laboratory, that is from NH4Cl and CaOH twice, and also how to prepare ammonia from magnesium nitrate Mg3, N2 and ALN. And then we have seen how to prepare ammonia by Haber's process, taking nitrogen and hydrogen in the ratio of 1:3, different conditions are there. Then we have seen about the funnel experiment. How can we make aqueous ammonia? Then we have seen physical properties. Mostly in physical properties, again we have seen about the fountain experiment. Then we saw all the chemical properties, and also we have seen aqueous, how the aqueous solution of ammonia NH4OH is treated with ferrous sulfate, ferric chloride, lead nitrate, zinc nitrate, copper sulfate. All these examples we have seen. We have seen about the test, and lastly we have seen about the uses. So go through the backside questions and prepare well with this ammonia, children. Thank you and God bless you.